Everyone, November the 6th. Alright, let's do this. Eliminate the maximum number of monsters. You're playing a video game where you're defending your city from a group of n monsters. You're given a 0-indexed integer array, dist of size n. Where dist I is the initial distance in kilometers of the ith monster from the city. The monster walked toward the city at a constant speed. The speed of each monster is given to you in an integer array speed of size n, where speed I is the speed of the ith monster in kilometers per minute. You have a weapon that, once fully charged, can eliminate a single monster. However, the weapon takes 1 minute to charge. The weapon is fully charged at the very start. You lose when any monster reaches a city. If a monster reaches the city at the exact moment the weapon is fully charged, it counts as a loss, and the game ends before you can use your weapon. Return the maximum number of monsters that you can eliminate before you lose, or n if you can eliminate all the monsters before they reach the city. Interesting setup, I should say. So in the first case, what I have, well, the distance we can always sort, right? So this is your city, and we have 1, 2, 3, 4. So you have monster at here, and here, and at here. And the speed is always was 1. And you have a weapon that takes a minute to charge. So in this case, at the beginning, right? At the beginning, the weapon is hot. So the weapon will always shoot every minute, right? And every minute it will shoot because you can always shoot. So at the beginning it will shoot, and then 1 minute later it will shoot, and 1 minute it will shoot. So it's all 3, right? The distance monster is this. After a minute, the distance of the monster, you eliminate the second. After the minute, the distance monster, you eliminate the third, right? Now in this case, oh, dude, you have 2 monsters. You have 2 monsters here. So at minute 1 you shoot, and then you lose, so it's 1. So basically what we're trying to see is how many, like, because the city when you shoot is one shot per minute, right? 1 shot per minute. So the question becomes, how fast can the monsters reach, right? And at each minute, the monsters will be at a certain position. At the start, minute 0, right? Minute 0, they will be at certain positions, right? And then the lead monster will be eliminated. And the next minute, right? And the lead monster will be eliminated. But if at a certain minute you have a monster that, I mean, you can calculate the amount of time it will take for the monster to reach, right? So in the first, the amount of time is 1, 3, 4, right? And the second, the amount of time is 1, 1, 2, 3. So we have at minute 1, right? At minute 1, we have 2 reaching. Yeah, so this is the amount of time that it takes. So in this case, the amount of time will be, 3 divided by 5. That's the first one. 2 divided by 3, and then 2, right? So that's the amount of time it will take. So what we need to know is, what do we need to know? Well, you will take some minute to reach, right? And if you can take less than 1 minute to reach, then yeah, you can only take out 1. Right, so we can get how much time it takes for them to reach, and then we can sort them based on from small to large, right? And then we can go through. The first one always can get eliminated. And now the second one that we need to see, right? The first one we can always get eliminated. Now we go to the second one, right? Now to eliminate the second one, the time has to be larger or equal to 2. If it's smaller than 2, yeah, 2 is fine, right? 2 is fine because you wait for 1 minute and then we're ready. Now we can boom, shoot it. So 2 is fine, larger or equal to 2. But if it's smaller than 2, then you can't, right? And for the third one to be eliminated, it has to be larger or equal to 3, which means in this case, right? In this case, if we have this is 2, then we can eliminate 2, right? We can eliminate 2. I think that makes sense, right? That makes sense. We get the arrival time, the amount of time for it to take to arrive. And then we know to kill each one, we need 1 shot. So to kill the second one, we need 2 minutes. Right, so we shot, what actually, no, is that 2 minutes? No, that's not 2 minutes. Because the first shot is 0. The second shot is 1 minute. So as long as it's larger or equal to 1, then we're good. Right? Then we're good. But why this one's not good? Because the first one's done. So this is, we say it's larger or equal to 1. But what happens is, you at minute 1, right? At minute 1, you can shoot. But at minute 1, it's already in front of you. So this is larger than 1. Larger than 1. Has to be larger than 1, larger than 2. Okay, so here is my solution. Alright, so speed and distance. So what we're gonna do is we're gonna have a float. Right, a float time equal to new float dist.length. Okay, then we say for int I equal to 0, I smaller than dist.length I plus plus. Then we say time I will equal to dist I divided by speed I. But how do we make this a float? By turning some of it into a float. Okay, so once we're done, we say arrays, now sort time. Okay, so we sorted. Now time is sorted. So what we need to do is int t equal to 0, right? And while t is larger than time t plus plus, right? And then one is larger, once it fails. So t plus plus, the next one it fails. That's when we'll return t plus 1. do you return t plus 1? Well, you do t plus plus, right? So t go to the next one. So when t goes to the next one and it fails, so I think I already have everything. So this is what I will return. And let's take a look. Does it work for everyone? Ooh, what the hell? All right, something is not right. Something seriously is not right. I'm not sure what happened. Is this some? I don't know. We sorted time t. No, I think it's smaller. I don't think it's larger. It's we have 1 if its time is larger than 1, which means t is smaller than, my bad. Yeah, it's smaller than, it's not, got the relationship wrong. Ooh, that is interesting. So while t is smaller than length, time.length, and that was good. Yep. Pretty normal, right? 1921. How do we say it? So the weapon can only shoot once per minute, which means the time that it can shoot is 0, 1, 2, da, 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 da. We need to make sure, right? We need to make sure that at time 0, 1, 2, da, 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 no monster has arrived at the city. We can compute the time needed for each monster to reach the city. Sort it from low to high, right? And compare it to the time when the weapon is ready, when it can shoot, right? If the weapon time is smaller than the monster arrival time, the monster can be eliminated. Otherwise, we lose the game. Alright, I'm pretty sure this is the... I think it's pretty optimal. I don't know if we can make it even more. Can take a look at the solution. Sort by arrival time. Oh my goodness. That is not ON, that's ON log n. Forgot about the sorting. Bum, bum, bum. Well, that's fine. Yep. A heap. Oh yeah, so... Oh, it might be faster, actually. No, that's fine. Alright, so that is good for today. Let's deal with this. Longest palindrome. I am not using Java for this. Go back to my comfort zone for this one. We're using Python for it. Have I done it? 5. Maybe I have. Oh, I haven't. That's good. We are going to use, right? So I'm gonna say the goal is to write Manacher from scratch. All right. We understand what Manacher is, right? We probably need to refresh the idea. So the Manacher is basically you have your string, right? And we have a DP, where DPI records what? I think DPI, oh, first of all, everything needs to be, we need to add these in between, right? And then we need to add a caret and this at the end. So DPI will be the length of half of the length of half of the palindrome, right? That's DPI, and I is just, this is 0, 1, 2, 3, right? DPI. Okay, so now as we handle that, so every time we have an I, we need to find out what we say there are two possibilities, right? Given a new thing, because we have, we have this is the current I. Now we keep the record of the maximum reach, okay? So we have a max reach is from some previous j, okay? And then this previous j has a maximum reach. So this is palindrome, okay? This is palindrome. Now, depending on whether the I is outside or the I is inside, we have some calculations to do. Now, if the I is outside the maximum reach, it's going to be the index. If it's outside, then what is its maximum reach for this? Well, then we have actually, I'm not sure. What if it's outside? This shouldn't outside doesn't count, right? So the outside is, you just have to extend. What if it's inside? Well, if it's inside, right? If it's inside, so we have a palindrome, this is a j, and that I is inside, then we have already this half. Well, we want to see this, so we find its position j. I'm going to say I prime. Right, we find its range. Right, so we find this, we get its range, and then here will be the same. Right, here will be the same, because these two are the same. Right, and then we can set a point here. Right, and then we have a point here. Then we just start searching outside, so start searching this, right? And if it's outside, then we just put one here and put one here, and then we start searching. Is that right? because that's all we want, right? That's all we want is, you know, if it's outside, then this one doesn't help. So we just put one here, and then we go both sides, right? We go both sides. And once we find it, we will extend, right? That's the maximum reach. Now once it's inside, we find its brother, right? Its mirror image. And from the mirror image, we can get from here to here, so we don't have to redo the inside. And then we go out. Okay, this is kind of how I think this will do. But exactly how we're gonna implement it. Well, first of all, we have to say list s, right? List s, and then we say this dot join list s, and we'll put this at the front. And put. Now in fact have to put this at the front and this at the end. So it's SS. Okay, so that's the actual thing we're gonna do. And DP is gonna be, now everybody will 1 at least. So times len SS. Okay. So for I in range 1 to len DP. Oh, we can say for I letter in numerate, not DPSS. That's not gonna work. I in range 1 to len SS. Right, so for each one of them, and we also have the max reach. Okay, max reach is equal to 0 at the beginning, because you're at here, right? At the beginning is 0. So now we are at the first one, okay? Then you say if your I, let's say if it's smaller or equal to, right? If I is smaller or equal to max reach, if this I is smaller or equal to max reach, what we need to find is its mirror. So we can say I prime, II, okay, II equal to, how do we compute this? So we have I, we have J. Oh, max reach. Nah, J is equal to 0. J, right? So smaller than J plus dpj, right? So we can say this is see if SSI is within previous max reach. Now J, because we are recording as the length, right? So if plus 1, that's actually not the max reach. Max reach is the number of, so it should start with 0. It's the number of the length towards the right and towards the left. So a plus 0, okay? So initially we have that. So if it's smaller or equal to, right? Then what we can do, we need to find this, okay? How do we find this? So we have I, we have J. Now what we can find out, so we know this is what we want, right? This is what we want. which means we need to compute this thing, right? I know I. Okay, I know I. I know this max reach is j plus dpj. Right, j plus dpj is the index of this. Okay, so the index of this minus the index of this, like let's say 1, 2, 3, 4. Right, index this minus index this is 3. Is the number on this, not including, right? Not including this, the number on this. So it's the number, right? Now in this case, that just means from here, we have 3. We have 3. Okay, 0, 1, 2, 3. Right? If we have 1, 2, 3, 4, so here 1, 2, 3, 4. So we have 3, not including this. So on this side will be 1, 2, 0, 1, 2, and 3. So my II shall equal to this, right? So II will equal to j plus dpj minus I. Okay? All right. Now j plus dpj minus I give you II. Let me just make this II. Okay, this is II. So now what we know is left and right, right? That's what we need. So we can say left, right initially will equal to I plus 1 and I minus 1. But if this, we're going to change, right? So left, right shall equal to left will be II, right? II minus dpii. Let's make sure it's right, okay? So II is the index, okay? So I have something, something, something. So we have the index. This is II. If I say the length is 2, minus 1 minus 2, that is correct. In fact, I need to minus 1 again, right? I need to minus 1 again. What if it goes out of bounds? So this should be minus 1, right? So if you want to compare, because we're expanding here, eventually we'll expand. No, we just want the size, right? We just want the size, the length. So it's not II, it's I minus this, minus 1, and I plus this. But then we need to take the smaller, right? We take the smaller. So we say the reach, I'm going to call it R, shall be I plus dpii. Okay, I plus dpii, and the max reach. So it shall be, right, the max, we can say max R shall be this, or j plus dpj, the minimum of the two. Okay, minimum of the two, because it might get out. But why would it get out? No, it won't get out, right? Because it's palindrome, so this will equal to this, right? And it will not extend beyond. It's not possible, because the max it can extend is all the way to here. The max it can extend, which means max it can extend is all the way to here, right? Which I think is safe. Yeah, I think it's safe. The minimum will be just 0. So I think it's safe. We can just do I minus dpii, right? I minus dpii, the maximum that you will get, right, is this one hit here, which is okay. Then we minus 1, right? And then this one will be I plus dpii plus 1, right? I mean, it will be like here and here. So that's our starting point. And then we keep expanding. We can say while, L is larger equal to 0, and R is smaller equal to ln SS, right? While this, if SSL is equal to SSR, man, then we say L minus equal 1 and SR plus equal 1, right? We just keep going out until we fail. We cannot go anymore, right? Once we cannot go anymore, we can say dpi, right? dpi shall equal to, because L and R is the index, so I can just say R minus I, right? R minus I is the number of reach. That is correct, right? And then we say if dpi, now if R is larger than, if R is the reach, right, you have more reach compared to the previous reach, which is J plus dpj, then we replace J or equal to R, equal to I. If it's equal, then we still prefer the previous one, then because we'll have more range to move. So blah blah blah, we go through the whole thing, right? Then what we want to find is a maximum palindrome. So we might as well, now we just go through this again, right? We can actually say max p length equal to 0, right? And then max palindrome index equal to 0. In fact, max palindrome length, yeah, it is 0. And then we say if dpi is larger than max palindrome L, max palindrome L equals dpi, and max palindrome I is equal to I. So we go through the whole thing. We have the max palindrome I, right? Oh, I just need the max palindrome I. I don't need the other one. So which is dp is larger than dp max palindrome I, then max palindrome I equal to I. Perfect, right? Now once we're done, we have the max palindrome I. So what we need to do is go from max palindrome, get to the end, right? We get the whole thing out, and then we'll split, right? So we can do SS from max palindrome I minus dp max palindrome I. This will give you the start all the way to max this plus dp max, and I hate this, let's call it max I, right? Of course plus 1. So we got that. We're gonna split on this, then we will dot join this, and we'll return this. Let's see how it goes. Does it work? Oh my goodness. Oh! You can do a test case. Oh, I forgot. I can do test case here. Ooh. Something is not right. Oh, of course. I'll just say this is equal to put it here. And this. Right? And if they're not equal, we just jump out. That was interesting, to say the least. Okay, so we need to copy and paste our previous stuff. No. I just want this. All right, let's do this. BABAD. Okay. This one is CBBD. Longest palindrome. S. That was good. Oh, answer. This should be BAB. This should be BB. Run it. All right. Time to figure this out. What are we talking about? Let's print SS first. Print max I. And DP max I. Okay. All right, this is correct. Max I is 4. 0, 1, 2, 3, 4. And we go 4. 1, 2, 3, 4. That's not right. Right? That is not right. Because this is not right. DPI should be R minus 1 minus I. And we can now use R to be R minus 1. What happened? String index out of range. It's interesting. How? All I did is make this change. Because once we, R is the reach, right? If you go out of bound, R need to minus 1, right? R need to minus 1. This should be fine because I say R has to smaller than this. What are we talking about here? Why? Why? Huh? What? What the hell? Oh, left. This is not right. Man. So many things wrong. Alright, this one's right. So we have like 2 things wrong. Okay, so this looks to be good. Do we have some other test case that we can go through? Oh, we have a bunch of test cases that we can go through. Let's go through this one. Bananas. Bananas. All right, let's try this. There's some issue. It's all right. I mean, you're trying to write Manacher from scratch. It is not going to be easy. Expect ACA. Yeah. It must be something that's wrong. Okay, so let's, again, the same thing. We're gonna print SS, print max I, and the DP max I, right? So why are we doing it multiple times? Because we're supposed to do it here. So 19, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That is bonkers. All right, so we have some very serious issue. Very serious issue. Okay. We need to deal with DP. All right, that's 0, 0, 0, 0. 1, because extend 1. Why would this one become 4? This one's 3. 1, 2, 3. 1, 2, 3. This is 3. Okay, this is 3. 3. Should be ACA, right? Should be here. And this become 4. Huh. Trouble. Okay, so the problem is we have something like this. Pound A, pound C, pound A. Pound A, pound C, pound A, pound A. Right. So this is your J. Right. It reaches all the way to here. Right. So that's because this is 3. 1, 2, 3. So now you are looking at this one. Okay. So now I is here. So I is smaller or equal to yes. So I, what's I? I, so this is 18. Right, this is 18. This is 19. So I will equal to 18 plus 3, 21. 19, 20, 21. Minus minus I. Holy crap. That ain't right. No, that's not right. The mirror is not mirror to the front. The mirror should be mirroring to here. Dude. So it shall be man, it should be j minus dpj plus this. Oh, so we're talking about 2 times j minus this. And that was the error. That was the error. Now I actually remember there should be a 2 times j. How many did we even pass in this one? Huh! With an error, we even passed so many. That was bonkers. That was absolutely bonkers. All right, check the previous. All good. All good. Go again. That is not expected. 115. What the hell? Doesn't matter. Again, just, you know, it's hot. A, D, A, D, A. Well, we have everything out. Run it. We have 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. A, D, A, D. That's not right. Yeah, A, B, A, D, A. That's not right. I have this go 5. This go 5. That's not right. Dude, that's not right. How do we even get there? Should be here, right? A, D, A, A, D, A, D. It should be this one. Oh, this is 5. This one's 5. But this one's also 5. That's not right. Hold on. A, B, A. Yeah, that's not right. How do we get this one to 5? All right. Let's see. Let's get a new page. It's all right. So we have this, B, A, B, A, D, A, D, A. Okay, so 0, 0, understandable. This is 1, understandable. This is 1. No, this is 0. That's correct. This is 3. That's correct. This is 0. That's correct. This shall be 1, 2, 3. That's 3. Understandable. So 0, 0, 1, 0, 3, 0, 3. Next is 0. It's understandable. Next, this is the big issue. I said 5, but it's not 5. Why did I say 5? Because the current reach is from here, right? From here, go all the way 1, 2, 3. Go all the way. Yeah, this is the current reach. 1, 2, 3. This is the current. This is J. And this is a 0, 1, 2, 3, 4, 5, 6. So this one corresponding to 6. Now we are at here, 7, 8. So this one is 8. It's within the range. So I say II is 2 times 6, 12, minus 8, 4. 0, 1, 2, 3, 4. That is correct. 4. Okay. And this is 3. Oh, it extends beyond. It cannot extend beyond. Dude. It cannot extend beyond. Which means, to the right it will not extend beyond, but this you can. I thought it won't. All right, that's fine. So we need to say a reach shall equal to what? Right, shall equal to what? Yeah. Shall be so the maximum you can get here shall be dp I minus maximum j minus dpj, right? J minus dpj and I minus dpii. So this kind of just reach back, right? How much back you can reach, and it will pick the maximum of them, and then we'll do I minus this, right? I minus this will be your reach. Because towards the right, it can be anyway, so we can just do that. That's the reach. Then we'll go reach and reach. Oh, what happened? What's happened to I? Yeah. So the max reach of II is restricted, right? Can be restricted by the max left reach. Can be restricted by the max left reach of J. Okay, then we try this one more time. They all pass. All right, let's run this one more time. It was fun, right? It's definitely fun. There we go. That's it. That was good. That was very, very good. I heard it's ON. Well, it took some effort, but I think it's well worth it and quite fun, to be honest. We can also check our previous implementation of Manacher. Oh my goodness, that is a better way of saying. Alright, I like this one better. Holy crap. We can join this. Ah. Padded left and right. One towards the end. Now here is, I do think that I have a better way of dealing with it. I shouldn't say better, but definitely more explicit, right? I think it's more explicit the way that I write here. I like how I do here. I think it's better than this. This is a little bit, you know, cryptic. This is more explicit. All right, that's it. Very happy that we got this one, and I can proudly turn this off. Manacher, very smart way. All right, that'll be it. I will see you guys tomorrow. Adios.